Hey everyone, and welcome to another edition of the Application Security Insights with Certus Cybersecurity. I am Falgun Patel, Associate Security Engineer, and today's topic is NoSQL injection or NoSQL. In this attack, an adversary constructs a malicious NoSQL query through a web client for backend database manipulation. NoSQL injection is like a SQL injection with an exception that NoSQL injection may include query objects, while a SQL injection uses special characters. Both SQL and NoSQL injections result in an unauthorized access to information. A NoSQL database is a non-relational database which does not use SQL for queries. A variety of NoSQL database types exist. We have picked MongoDB for today's video. MongoDB does not follow a query language, making it impossible to break out of a query syntax by using special characters. Let's consider this example where we compare a SQL and a NoSQL query to authenticate a user's credentials. In both these cases, user input is still embedded into the query without any validation or sanitization, which puts even NoSQL databases at risk. However, special characters are not usable with NoSQL. Instead, special database operators must be used to change the intent of a query. Here are a few common types of NoSQL injections. In our case, we'll focus on the classic NoSQL injection. MongoDB stores objects in the JSON format as shown here. Let's start with a high-level diagram of a classic NoSQL injection that is representative of either GET or POST HTTP request. An adversary constructs a malicious NoSQL query and enters it as user data through a web client. The database then executes the code as a legitimate database query and returns data outside of its intended context. To showcase the impact of NoSQL injection, we have created two vulnerable PHP web login pages where one accepts login via HTTP GET request and the other accepts login via HTTP POST requests. Since PHP is a server-side logic, the only code visible in the web client console is HTML. For a basic authentication bypass, an adversary can try to enter MongoDB operators in field values like $EQ, $NE, or $GT. Here's an unsafe way to build a database query in the PHP application using a POST request, where the parameter values are taken directly from a user's form entry. The server-side logic portion takes untrusted user data as input to the query. In this snippet, POST username retrieves the user data and passes it directly to the find method helper for building the query. If this query is then used to check login credentials, the adversary can abuse PHP's built-in associative array processing to inject a MongoDB query and find all users where the username is not equal to 1, which is highly likely to be true and may allow the attacker to bypass authentication. This may be as simple as sending the following POST request. The adversary can also leverage these operators to exfiltrate credentials of other users in the collection. Let's look at a few other ways an adversary can exploit our insecure PHP application to dump user credentials for all the other users. Here are the results of exploiting the PHP application via a GET and via a POST request. So how do we protect our organizations against NoSQL injections? We use typecasting to initialize POST parameters as string literals and filter out all other data types. Defense in depth will, however, require a combination of these mitigating options. Thank you so much for joining us today, and please don't forget to comment what kind of videos you want us to cover next.